after gluing two prevarieties in the previous video, now we want to do the case of 3 or more prevarieties, but still finitely many. And the construction is very similar to what we have seen before. So let's say we have a finite index at I, and xi is a prevariety for all indices in I. And moreover, suppose now we need to do the overlap. So suppose we have that's uij in each xi for j not equal to I, together with isomorphisms from uij to uji, which sits in xj. And before this was already enough, but now in the case of 3 or more prevarieties, we need some extra conditions, namely because we allow now also to go from j to I, so we wanted the morphism from here to there is just the inverse of this morphism. And there is a compatibility on triple overlaps, which in formulas is saying, well, on the set where this map is defined, you want that Fij post-composed with Fjk is equal to Fik. And in the picture, this just means if you're here on xi, and you are at the point where you can go first to here and then to here by these two transition maps, you should arrive at the same point as if you directly take this transition map here. And this kind of makes sense because you want that everything in the end can glue together to a single space. The slogan here is transition maps taking somehow the detour via xj shouldn't matter. You can directly go to xk in one go. And if you are satisfied, or if these conditions are satisfied, then you can set first of all as a set x to be, just take the disjoint union of the xi and then mod out by an equivalence relation. This equivalence relation is saying A should be equivalent to Fij of A when A is in one of the overlaps, and every element should be equivalent to itself. And then these conditions, A and B, exactly say that this tilde is symmetric, and the second one says that it is transitive. So it basically comes from the properties that we expect from equivalence relation. And so with these properties, this is indeed an equivalence relation. So we get a well-defined set X as before, and then we can define the topology and the structure sheaf just as we did it in the case of two prevarieties. And that makes X into a prevariety obtained by gluing the Xi along these identification maps Fij. And you can see all of the Xi as open subsets, even as ring space in this new prevariety X. And as an example, so we're going to see this example in much more detail later, but just to give you one non-trivial example of such a gluing data, you can take 3 copies of A2, the affine plane, and for kind of simplicity of notation, I want to denote on these 3 copies, U0, U1, U2, the coordinates in different ways, as indicated here. And then the uij in these coordinates is defined as the x such that xj is not equal to 0. That's certainly an open subset. And then here I have written down the 3 gluing maps, which are defined, and you can check an exercise. And that's kind of a purely formal check on these functions, that the above is indeed gluing data. So it's well defined. This maps uij to uji, and it has this triple compatibility condition. And so at least on a formal level, you can verify this must glue these 3 copies of A2 together to some space. The space will be called P2. It's covered by these 3 affine planes, and it's called the projective plane. And in the next chapter, we're going to see an interpretation of this projective plane why would we choose exactly these kind of weird overlap conditions. And then we're going to continue working with this. Okay. And as a final note, we have by definition that any pre-variety X has a finite cover by affine varieties. And then if you set Uij to be the intersections of two of these covers, then while Uij and Uji, because intersecting sets is symmetric, they are just the same set. So you can take the identity, and then this gives a nice morphism. You can check the identity satisfies these triple overlap conditions, basically because composing the identity twice gives the identity again. And we can recover X, the given pre-variety, by gluing together these Xi. And this shows that the buff construction is pretty general because any pre-variety X can be obtained via this construction from affine varieties Xi. So in principle, now we have the ability to construct every pre-variety from some finite known data.